Okay. Earlier we saw differentiated service or deep serve, hop by hop QoS, per hop QoS, which is also called as deep serve, differentiated service, which means on each router we may have different prioritization for the same traffic. One router may give more importance to management traffic like telnet and SSH, whereas the other router gives more importance only to SSH, not to telnet. Now, just an example, per router behavior, per router. Now, to do this, you need to classify the traffic. On one router, you have to classify both telnet and SSH together because you give same priority. Whereas on the other router, you give telnet less important and SSH more important. So you need to have two different classification. So how do you classify? By using class map in which you match the traffic like SSH and telnet and go to the policy map and you're going to mark it with some unique identification. If SSH and telnet have got different service, then for SSH you will give one marking, one identification, and for telnet you give another identification, another identifier. You see, then you need a lot of identifiers. You may have many policy for different protocol. You got different policies. So how we are going to do this? You need more options, more markings. That 3-bit marking with which you will get 7 identifiers, not sufficient. You want more. For that only we go to this one called DSCP. That IP precedence that you saw earlier, which is giving only 3-bit marking, is not sufficient. IP precedence is also a layer 3 QoS, but that is not sufficient enough when you have many policies, many protocols to match. So differentiated service code point provides you more markings, more identifier, because it is using 5 bits. Totally, you got 6 bits in layer 3 QoS, in which the last bit is not at all used. And you got this 5 bits, but the 6th bit is also considered, though it is not used, it is considered in calculation. Where it is not used, it is not used in default identifier table, but it is still considered globally when you have a custom marking. So I don't want to say DSCP is 5-bit. The default markings of DSCP are AF and EF, expanded forwarding and assured forwarding. In that, you won't see this one, the 6th bit getting considered. But when you have a custom marking, you can utilize that. But not much, people are interested in using it. But when you calculate, you need to say 64 different markings. If it is only 5-bit, you will not get 64. 1, 2, 4, 8, 16. If it is only 5-bit, you will not get 64 different identifier to mark. Only when you have 6 bits considered, the total will be 0 to 63. 0 is also a marking to say no QoS, very least prioritized, high prioritized. So this is considered. This is the proof. It is not 5-bit, it is 6-bit. But when you see the table of this DSCP, you will find only this 5-bit. You should not get confused. For custom QoS, for having your own marking, you can have all the 6. But when you're going with the DSCP's default AF and EF, assured forwarding and expedite forwarding, you will see they don't use those that particular one last bit. And this also they will use like this. This one 3 separate, 1, 2, 4, and this 2 separate, 1 and 2. This is how they use to create multiple high risk and low risk markings. I'm talking about this table, which you might have already seen. You see, high risk of dropping is this one. Low risk of dropping is this. And if you see here, they have put this particular one always 0 everywhere. And also when they calculate, they don't include that. They see this 2 and get this number, and they see this one and they get this number. They see this 3 number, you see 4, and this 3 number, 2 plus 1 is 3. So this is nowhere considered in calculating this AF or EF. That is what I was telling you. AF, EF do not consider that 6th bit. Right. So as we already saw, DSCP is providing you more granular, more marking options, unlike IP precedents. Here is the difference in the table. Nice. I don't want to go with those pages. It's summarized and put it here. You see, IP precedents is 3-bit, DSCP is 6-bit. You can give a reading of the previous page. I'm just holding this. You can pass it and see. You can pass it and see. All right. So this is what explained there in previous pages in detail. Where to use, where we will use. IP precedence is used when in a small network where you got very less number of traffics to match, less number of protocols to match. Whereas in a large network, you need more granular control over all protocols. With this per hop behavior, means every router needs separate prioritization. Then DSCP is needed. IP precedence is old one, legacy. DSCP is what currently used in various, widely used in modern networks. Yes, DSCP and IP precedents are compatible because IP precedence is nothing but basic DSCP. IP precedence is nothing but basic DSCP. DSCP, you got 6 bits, and this 3-bit is what basic DSCP, IP precedence. IP precedence is only 3-bit. If in IP precedence you have 101, and what is the value then you get? You get 6. Here also 101, you will get 6. And this one is separately calculated. Then in DSCP it is 62. In here it is only 6. In 6, this is more granular. So what I'm trying to say is DSCP and IP precedence are compatible. Right, I was talking about this AF and EF. Expedited forwarding is the toughest default, high priority and low risk marking. Low risk of drop and highly prioritized marking is EF, expedited forwarding. EF is designed for voice traffic. This class have got low risk of drop because it is prioritized in the network. In fact, the packet with EF will never get dropped. It's the lowest risk of drop. Whereas in AF, you have different levels. For example, you see AF41 and down there AF11. AF41, among all AF marked traffic, AF41 has got high priority. Compared to EF, this has got less, but between AF, this has got high priority, and AF got the lowest. AF11. AF11 has got the lowest compared to AF41. But when you compare this one to this one, this is the highest priority, lowest risk of drop. This has got moderate risk of drop. This has got lowest, the lowest, which means EF is highly prioritized than AF. I shared forwarding. AF41, 4. The first number, if it is bigger than the other first number, which means when the congestion happens, the lowest AF value will get dropped. The first number is different, and the one with the lower number will get dropped when there is a high congestion. See, when there is too much of congestion, you have to drop some traffic to reduce the congestion. And which one to reduce? The one which has got the lower value in the first hundreds place and tens place. Tens place mathematics. In tens place. Not in ones place, you focus on the tens place. Ones, tens place. You understand, no? The word tens place. Second number from the right, huh? Second number from the right. Okay, that is AF classes. What is BE then? BE is best effort, meaning there is no marking, no QoS marking, which means it will get matched with the default class and the default treatment, normal routing. So when congestion happens, before this AF11 get dropped, which one will get dropped? This will get dropped. The packet with no QoS will get dropped first. Highest risk of dropping. All right, because it has got no any QoS. So under the congestion, this gets dropped. All right, so it is from the lower to top, down to top. This has got the lowest and little bit more care, more care, much more care, much more care. The most carried, most controlled, prioritized, focused traffic. So these three terms are there in DSCP. Best effort B, assured forwarding F, expedient forwarding F. Assured forwarding has got various classes. We are going to see that in coming pages. I showed you the table a few minutes before. You need to understand that to understand AF. Whereas EF and BE, there's nothing much to understand here. If you have EF marked for a traffic, or if you want to mark a traffic with the highest priority, then you just go and say DSCP EF. Only one EF you can have for one class. You can have EF. All the traffic that is marked with EF will go in one priority queue. Only one. This is the table of EF. I shall forward. Common DSCP values along with their corresponding classes. This is all common, by default prescribed by the standard. See, we saw DSCP 64 different marking, but you don't have 64 markings here. This is just the default. You can have your own custom marking. This is common DSCP value. Most of the people only use this one. They don't use all 64 that you can have. Right now, the meaning of these things we need to understand. We need to understand the meaning of EF22, EF41. That's why we are here. Common DSCP values along with their corresponding classes and the associated risk of packet drop, particularly in a congested network condition, these things are needed. Let's say we have packet with all these markings. We got millions of packet coming in into a router's interface, millions of traffic with different type of, some are marked with AF23, some are marked with AF32, some are marked with AF11, some are marked with AF43, some are marked with AF41. It is coming, and there's a congestion. It's a congestion condition. Now, in the congestion condition, how this is prioritized? See, you have to drop some traffic to avoid congestion. First, it will drop all the traffic with no QoS called BE, the best effort, no QoS. Even after dropping that BE, if the congestion is still prevailing, it will see the markings in the packet. Let us assume that the markings are like this. All the packet currently we receive is having only this three marking, assume. Only these three marking. All the millions of packet that you are getting, they got only this three marking. Now I need to drop some traffic in order to reduce the congestion. Which one to drop? In the ones place, the bigger one is bad. In the ones place, the bigger one is bad. Ones means what? The first number from the right. This is tens place, isn't it? So in ones place, bigger is bad. So this AF13 will get dropped, all the packets among that million, with AF13 will get dropped first. AF13 will get dropped first. If still congestion continues, only then this will get dropped. All the traffic with this will get dropped, and this will never get dropped. Because I told you the traffics are only having these three markings. Among these three, this is highly prioritized. 11 is more weightage than 13. Small number has got more weightage than big number if the traffics are from the same class. That's what here it is saying. High drop possibility. Slow drop. Yeah. Within the same class, this is the dropping procedure. But if you take between the classes, let's say you got millions of traffic with all these four classes. Now, which one will be dropped first? The tens place, whichever is smaller, will get dropped first. One is smaller than 4. All the packet from class 1 will get dropped first to reduce the congestion. If congestion still prevails, then class 2. So that these two will never get dropped. But if still congestion continues, it is going to drop class 3 so that this will never get dropped. Right, so if you see within the class, small number is good, but between the class, big number is good. 41 is good, will not get dropped. 11 will get dropped. Now, how is this AF11, AF41 and all comes? As I told you, out of 6 bit, the first 3 bit and the second and the next 2 bit and then the last bit. The last bit will be always 0, don't consider. This is taken as 1, 2, 1, 2, 3. This type of separation so that this can be compatible with IP precedence. For IP precedence, it will not consider this 3 bit, it will consider the higher order 3 bits only. Higher order 3 bit of DSCP. That is how it is compatible with IP precedence we learned in the previous pages. Here, compatibility, basic DSCP. All right, now let's take this one. It is written AF32. For AF32 here you see 0, 1, 1 and then 1, 0 and last number is 0, which is here. So because they have grouped like this, you will understand it easily. 3 and here only 2 is on to 32. If you don't know to separate this and calculate, then you will be confused how this becomes 32. If you simply see these things as one big binary 0, 1, 1, 1, 0, 0, you will not have this clarity how this 32 comes. If you don't separate 1, 2, 4, 8, 16, 32, don't need to focus on this because they got 0. So 16 plus 8 plus 4 is 28. But here it is 32. You'll be confused how this 32 and 28 tallies. It won't tally. So you need to understand that the bits are grouped like this. 0, 1, 1 and then 1, 0 and then 0. This is separate, this is separate. And this is not considered. So this is 2, this is 4 plus 2, sorry, for the 2 plus 1, 3. Sorry. Now you do one and see yourself. 1, 0, 0, 1, 1, 0. Check whether you are getting AF43. Now, do it. Did you get this? Why no answers? Okay. Mithun sir, how about you? I didn't get any response from your side, sir. Are you there? You understood that 43 AF? Okay, that's great. Now, if you know all this thing, it is good time to go understand the configurations of different type of QoS. For that, we need to revise this thing which we have seen already. Traffic policing means what and traffic shaping means what. This is a kind of congestion management. How do you control the congestion? Either by dropping some traffic. See, when you drop some traffic, congestion can be avoided. No, let's say you are running a school, and the school is in the main road, right on the side of the highway. If all goes at the same time outside, like people coming from a marriage hall in India in a congested area, for the public to use the road, it becomes very difficult, you see. I have suffered even last night. All of a sudden, the marriage got over, our reception got over, everyone is on the road, and the entire car was parked on the roadside, and all wants to start the car, get into the car, and they never allow other public, common people who are using the road to cross that area. They fully block the road. And for them to clear and go further takes time, a lot of time. It is because there is no proper congestion management. If it is school, school is a disciplinary, the place where the discipline is taught. I don't know whether it is true today. No one agrees today that school is discipline. That's the place where one children learn bad thing from the other children, which means we are in the evil world. But school should be the place where disciplines should be taught, people should be molded, more cultured. But it is an opposite now. Very sad part. Now let us say there is a school with a good, knowledgeable, talented human being managing the school, not the devils in the management. Let's see such a nice management with good godly thinking. How will they can avoid congestion? They won't simply ring the bell and open the gate and let the children go and get hit by vehicle. Not that devil spirit. Knowledgeable, good, godly spirit, good schools will do like this. They will say, okay, when the first bell rings, these classes only will go. So what they do is they make the other class children wait. If all goes, problem, congestion for the public. So they say when the first bell goes, only the primary and kindergarten can leave with a parent or with the bus. Done. And then once no congestion is seen outside, you can see that through the CCTV camera from the office room. When there is less congestion or no congestion, then you ring the next bell. Now classes from maybe 5th, 6th, 7th can leave. Till the time they leave, the other classes like 7th to 12th, they have to wait. This is what we call it as shaping. We are slowing down. We are making some to wait to avoid congestion. We send it in control. That is shaping. For example, you want to send 2 GB of data. If you send 2 GB at the same time in one big bundle, problem, congestion. So what do? You shape it. You see the capacity. You see how much the ISP will allow you, how much you subscribe with the ISP. What is the bandwidth committed to you by ISP? Within that bandwidth, you shape it. Within that bandwidth, you shape it. You send it within that level. You send it within that level. Excess, you put it in another queue, slow down. Allow this one important to go fast, less important you slow down. Who is less important in the school? Compared to primary and kindergarten, 12th standard is less important. 12 people can wait. 8th standard children can wait, but not the kids. This is what called shaping. Yeah. Now, policing is not like that. Policing is like what I said. The the marriage hall, reception hall in India. As soon as that as soon as something gets over, they immediately come and they block. So what will happen? The police will come. What police will do? They will stop all of them coming out from the marriage hall so that the traffic will be cleared. The common road, public can use the road. They will say, no, close the gate. Don't allow anyone to come in, come out. This is very high peak hours. This is not the time you people can come and block this road. You want to celebrate someone's marriage, enjoy inside. Don't come outside till this time. For them, the service is totally denied. Khatam, khatam. Fully, stopping the service. Here in traffic policing, what it is, in networking, traffic policing, if 100 MB is committed, only that 100 MB will be permitted. All other will be dropped immediately. No wait, no slowing down, nothing. Drop it, drop it. Don't allow, finish. You're not supposed to come to the road. Drop because you are excess. Committed is only 100 MBPS. All the excess, drop it, drop it, drop it, drop it. Whereas shaping is when the excess comes, it will be placed in a low priority queue so that it can be sent later, slowing down. That is shaping. Whereas policing is dropping. We are going to see the configuration difference for both. See, traffic policing is an important aspect of network management, helps to ensure the traffic confirms the specific profile and the bandwidth. Traffic policing is traffic should be within the specific committed information profile, specified profile, which is bandwidth limit. Let's assume that you have a router interface where want to apply traffic policing to limit inbound from specific VLAN, only 5 meg inbound. If anything more than 5 meg, drop immediately. This is the configuration steps. You have an access list. So here is the access list to match the traffic of VLAN 10. This is the traffic in the VLAN 10. Okay. So this 192.168.10 is the traffic of VLAN 10. We are now, first of all, matching it. Classify. That is called class map, classification. We say this particular traffic. See, what is the previous example? For this traffic coming from VLAN 10, I should set policing of 5 meg, meaning I need to tell the router, make sure they are only 5 meg traffic. If more than that comes, drop it. That's what I want to do. For that, I first say which traffic, sorry. I first say which traffic, and then I say, so this is what which traffic. I call the access list under the class map using this command. I'm calling this here. So I have now said which traffic. Now what to do with that? This is what you need to do. Policy map, give any name, call the class which you created. In the previous page, you created this class called traffic policing. You see, traffic policing. Traffic policing called class map. Now you are calling that class map here, and only for that traffic of VLAN, you say 5 meg, and this is grace. You know, grace. When I was a small boy, the milk vendor used to come to home only. Nowadays we go to the booth, milk booth, and we collect milk in a plastic cover. In Bangalore it is called Nandini. In Chennai it is called Avin. We collect 1 liter cover, half liter cover, like that. But early days there used to be a big can behind the cycle. One milkman will come to every house and ring on bell, ding 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 ding, and then he will know the milkman has come. We go with one bowl. If you ask 1 liter, he will pour 1 liter, and then he will also pour some 50 ml free. You are paying for 1 liter, but he will pay 1 liter plus. In front of you, he will take little bit more from the tap and he will pour you. He used to pour me when I buy. I don't know whether he poured you or not. But we are paying only for. I was paying only for 1 liter, but he is paying. He is giving 1 liter plus 50 ml. Like that 50 ml is what this 8 meg, 8 kb, 8 kilobits. 5 meg is the granted one. 5 meg is the agreement. But ISP says it is okay, man. Little extra, let us give 8 meg. Sorry, 8 kilobits, 8 kb. Let's give 8 kilobits excess. What to say? Bonus. 8 kilobits bonus. And if the traffic is within that 8 kilobit excess, if the traffic is 8 kilobit is excess, and if it is within the 8 kilobit excess, action is transmit. Allow them. If exceeded, this is policing. Drop. Immediately you drop. No courtesy, no grace. We already gave bonus 8 kilobits. No more bonus. No more mercy. This is what called as policing. Drop. If you use the option drop, it is called policing. Next, here in this example, they are putting as an inbound. Yes, usually it will be an inbound. ISP will put this inbound. They will. This is the interface to which the customer is connected. Customer edge router is connected. Customer is sending the traffic to this interface of ISP router. As the traffic comes in, ISP is doing policy. So you call this policy map called traffic, and you say when any traffic comes in, if this policy matches, this is what you need to do. You have to take a strict action. Make sure the customer is sending only 5.8 meg. 5 meg is committed, 8 meg is bonus. Sorry, 8 kilobit is bonus. So 5.8. All the rest will be dropped. All right. So what you saw is policing configuration example. First, you wrote the access list to match the traffic, and in the class map, you call the traffic. That is what the whole matching is done. Now go to the policy map to take the action. The policy map, we set the maximum of 5 meg plus grace 0.8, and then and if something more comes, drop. And we applied the policy map to the interface. Right? And if you want to verify whether this QoS is functioning, during the congestion time, you put this command. During the congestion time. See, only when the congestion happens, means what? Only when excess happens, you will see dropping. 5 meg is committed. If he's sending more than 5, it means congestion. It means exceeding the rule, exceeding the policy limit. You will see the dropped. It will show you, if you type this command, show policy interface geek01, it will show you how many packets were using this policy. And if any excess would have come, it will show you how many packets got dropped. How many was sent, how many were dropped. In another word, how many bits or megabits were within the policy and how many exceeded the policy. It will show you both in bits as well as in number of packets. How many millions of packets have been sent, how many hundreds of packets has been dropped. It will show you. This is the only verification command for QoS. You just see the status under the interface because you bind the QoS on the interface only. Show policy map and then you put the interface name. Do you have any question on traffic policing? Okay. This one? See, this 8,000, if you repeat 2 times, what does that mean? Or if one is 8,000 and another one is 10,000, what is the meaning? See, some people will have a policy like this. 5 meg is the allowed one. You can allow them to exceed from 8 kilobits to 10 kilobits. 8 to 10 you can allow. That is what, policy. Then you need this to set the upper excess. And this is minimum, this is the maximum. Like people used to say, no, how much will be the excess, man? The price should not be more than 500 rupees for this earpod that you want to buy. Sony earpod. Original is costly, but duplicate, it should not exceed more than 500 rupees. But it can go between 525 to 550 rupees, depending on the your negotiation skill. It may go between 525 to 550 rupees, which means 500 is the actual price for the duplicate AirPod of Sony. But depending on the negotiation, depending on the shop vendor's skill, they may go for one shop maybe 525, one shop maybe 545, one shop maybe 550. And it is telling that it cannot go more than 550. Likewise. This bonus also you have some grace range, 8,000 to 10,000. If you have only this two option, you can do that. If you have only one, then you cannot set lower and upper limit. Okay. Any question? No, here 8,000 means 8,000 and 8,000 only. No 8,001, 8,002, no 10,000 under. 8,000 and 8,000 only. That is okay. That is allowed. That's allowed. No, not like that. 8,000 is what we want to give extra. And what if some important traffic in that takes 8,000 also has come. So I don't want to drop that important traffic. Let me say 8,000 to 10,000, something like that. So see, sometime this 8,000 will become a problem. You say 5 meg and you say 8,000, but in that 8,000 quota, some important traffic with 8,010 has come or 9,000 has come. And I don't want customer to complain. So I say, okay, fine, 8,000 to 10,000. So that important traffic that is coming in a bonus quota with 9,000 should not get dropped. That's the idea. Yeah, correct. Well, okay, any other question? Okay. Now, next is shaping. Shaping is almost the same, but only thing is the exceeding excess traffic will be placed in a low priority queue. Exceeding traffic will not be dropped, rather, it will be placed in a low priority queue. You see, same way, you write an access list like before. Example, the access list is 101, another access list is 102. Access list 101 is matching with the voice traffic, UDP traffics. They are very sensitive. Access list 102 is connection oriented. UDP, if it is lost. If it is TCP, it can be recovered. So you are getting low priority traffic called video streaming and getting a high priority, high sensitive traffic called VoIP, voice over IP. Now you are writing two class maps, one to match the voice over IP, highly sensitive, and comparatively low sensitive. Two class map. And then you go to the policy map called traffic shaping. Any name you can give. This can be Kuppan Goendsami. It can be any name. It can be any name. And you call the class map and you set priority. Priority is a special queue, and that queue is the highly prioritized, means high importance is given. That's why it's called priority queue. And you are setting bandwidth of 100 kilobits. What is the question? No. This is a type of queue you are creating, not EF and all. This queue's weightage is high. No EF, no AF. That's a marking story. This is not marking. This is queue name. You are creating a queue called priority queue with 10,000 bytes. That's bytes actually, 10,000 bytes. And you are creating another queue with 500 bandwidth, 500 byte bandwidth. So two queues are created, another one fair queue. This we don't know how many queue, it depends on how many sessions and how many type of traffics that comes. So what I'm trying to say is, this is your big interface. Here you have created one queue in that interface. And this is only 1 MB, 1000 kilobits for voice. Voice are tiny traffic, that is enough. That is enough. So all voice traffic will get inside this and it will never get dropped, never disturbed. And you create another queue, a little thinner, with 500 or half meg, 0.5 meg. And for all the rest, you have these place, number of queues that will be automatically created depending on how many sessions. Now when congestion happens, only the lowest queue will get dropped and then the next one, then the next one, next one. So these things will never get disturbed if disturbed only maybe this TCP tunnel, but not this UDP tunnel. So you see the fair queue is nothing but a dynamic queues. They're automatically created depending on the flow. But you don't give any bandwidth or any priority for that. They are automatically created and then they will be flowing. Once the flow, once the session is over, the tunnels will get broken. But you have a fixed tunnel of 1 MB for voice and a half MB for this video, a reservation. For others, you don't have a reservation. All right, now this is what we called as shaping. For voice, you have put what? This much. What if voice traffic is more than 1 meg? It will be placed here automatically. What if TCP traffic is more than this? It will be placed here. It won't get dropped. It will be placed in a low priority queue. There is no dropping here. Whereas in this example here, you got only one queue, and if excess happens, it is dropped. Only one queue inside the policy map. But here you see you have 3 queues inside the policy map. 3 queues with different prioritization. So what you see here is if any excess traffic more than 1 meg comes from voice, it is not going to get dropped, it will be placed in the low priority queue. So that it can be served There will be slight difference in the delay in delivering, but they are not dropped. As usual, you go to the interface and you call the policy map. Usually customers do shaping. That's why out, and this is connecting to the ISP. We control the traffic and send out so that it won't get policed by the ISP. Is this clear? Policing and shaping is done. Is this clear? What about others? Okay. All right. Queue management. So there are different types of queues: weighted fair queue, and then low latency queue, class-based weighted fair queue. This is low latency. These are the three main stories actually left in QoS. Priority queue, I already showed you in shaping. Priority queue plus weighted fair queue is what called as low latency queuing. This one. I think I have to put this for another day. Just one more day, we will finish this. I want you to go through this. We have seen two things. One is traffic shaping, another one is policing. We saw the configuration. Do this and see in your command line. These two exercise. Before that, we have learned DSCP. Now, why we didn't use DSCP? Because it's coming. It will come when you go to CB, class-based weighted fair queue. See, weighted fair queue example also using EF here, and then class-based weighted fair queue CBWFQ will also use DSCP values. For this only we have learned, we will be using this DSCP in our next class, which you learned today in the beginning. As of now, we have two labs to do. One is the traffic shaping, the other one is traffic policing. Instead of me doing, it is better you do it because the commands are very clear here. I'm going to just type the same thing. And better you do, you generate some traffic, you do this lab and see the output. And if you will face any difficulty or if after doing, if you want any clarification, explanation, I can help you with that. Right?